So the big picture for this lesson is quadratic functions, and we're looking at making graphs in intercept form and in standard form. So intercept form is like this. Okay, so f of x equals x minus 2 times x plus 4. So what you can do is you can use each one of these factors to get your x-intercepts. So in this first one, x minus 2 equals 0. So x equals 2, because you add 2 both sides. X plus 4 equals 0. Subtract 4 to get x equals negative 4. So then you can plot those points. X equals 2. X equals negative 4. There are your intercepts. And then how do you finish the graph from there? Well, you find the axis of symmetry, which is halfway in between the two intercepts, and that looks like it's right here. X equals negative 1. Okay, so there's no vertical stretch or shrink, so all I need to do is figure out the distance from the axis of symmetry and then square it, and that tells me where to put the vertex. So the distance is 3, so 3 squared equals 9, so that means my vertex is going to be 9 away from the x-axis. And since we have a positive leading coefficient, the parabola opens up, so I'm going to go 9 down, and that's where my vertex goes. Right there. Okay, so that's all you need to draw your parabola is those 3 points. Okay, something like that. So that's using the intercept method. I like this one because, if you really understand what these factors mean and also understand the pattern with parabolas and the perfect squares, this is super easy. Now let's look at another technique. Now let's look at standard form. Okay, now when you have a function in standard form, you could write it in vertex form or write it in factored form or intercept form if it does factor. Or you could just graph it from here. And what you can do is you can use x equals negative b over 2a, where the coefficients are a, b, and c. This tells you the x-coordinate of the vertex. So here we have a negative of negative 4 divided by 2 times 1. So negative of negative 4, that's 4, divided by 2 times 1, which is 2, and then you get 2 here. So 2 is your x-coordinate of the vertex. How do you find the y-coordinate or the vertical value? Substitute the 2 into the function, see what the output is. So you do f of 2 equals 2 squared minus 4 times 2, and then minus 6. Make sure you're careful with order of operations here. 2 squared is 4, and then negative 4 times 2 is negative 8, so minus 8, then minus 6. 4 minus 8 is negative 4, then minus 6 equals negative 4 minus 6, which is negative 10. So 2, negative 10. There you go. And notice I was very careful with the order of operations. It's very easy to make mistakes doing this type of evaluation. So right 2 and then down 10. There's my vertex. So then I'm going to apply a perfect squares pattern. There's no stretch or shrink, and the parabola is opened up because the leading coefficient is a positive. So right 1, up 1 from the vertex, then right 2, up 4. Then right 3 and up 9. Then I'll reflect the points over the line of symmetry, which is at x equals 2 right here. And I can draw my parabola. Okay, something like that. So that is graphing in standard form. And there are also going to be some applications in this lesson for projectile motion. And those are really interesting because it's all about either dropping an object or throwing an object in the air. And that's probably the most common application of quadratic functions. So that's the big picture for this lesson.